Hi everyone, this is part 2 of DIY CNC with a novice. In this episode, or this video, I'm looking to install Arduino and we're also looking to install GRBL onto our Arduino Uno, which will control the CNC shield. I'm also going to run a program called Universal G-Code Sender. What that does is allows us to control our motors and also visualize our G-code files and also send the G-code through to the CNC board. So we'll get all that set up. Also, lastly, we better make sure that everything's connected too. So we'll be connecting our stepper motors to the CNC shield, making sure we have the correct steps set on the CNC shield, and installing our little drivers as well into the shield. So stick with me. Hopefully we're looking go about 25 minutes. That's the sort of the aim of this one, and hopefully at the end of that 25 minutes we can get these machines or get these motors turning. So stay tuned.
Okay, so first thing we need to do is go to the arduino.cc website, because we need to download Arduino so that we can talk to our Arduino Uno. Now I've got a Windows machine, so I've gone ahead one step further. I've downloaded the Windows installer. So from here, we click on it and just follow through. Agree, all the prompts. Yes, install, and let the install go. Okay, so now that that's completed, all we do is click on close, and we should have an Arduino shortcut on our desktop, which we do. So next thing we need to do is connect up our Arduino board via USB to our machine. And once that's recognized, installing device driver software. Now, there were some issues apparently with this where people were saying that wasn't installing properly, but I've found that it actually installs without issue after you've installed the software and then you plug it in. So we'll see if it happens this time, because I've done this once before and I just uninstalled all the software because there was a later version out, and I thought we might as well record this as well. Okay, so that installed successfully by the looks of things. And what we'll do is we will open up, oops, wrong window, Arduino. This is the new configuration. And we'll see automatically down the bottom, it's detected Arduino Uno on COM18, which is my COM port. So just to double check it, it's selected the Uno and it's selected the COM port as 18 and Arduino Uno. So it's now connected. What we want to do now is install GRBL onto our Arduino. Now we need to go to the GRBL website. GRBL website at GitHub. And download the zip file. And once you've downloaded the zip file, we need to extract it. Now, there are some, if we go to click on the wiki, there's flashing GRBL to an Arduino via the Arduino IDE. This is what we'll follow because we've got this up and running now. So what I'm going to do is I'm going to unpack the file into the folder as per the going to compile GRBL wiki page for instructions on how to compile upload GRBL. So let's go here. So first thing, we've downloaded the source by hitting the download zip. Once downloaded, unzip it into a folder called GRBL master or something similar. So we shall go and do that. Okay, so I've extracted the file. So what we're going to do is we're going to follow these instructions and run through this. So we're going to go to Sketch, and we're going to go to Include Library and add a zip library. It's come up here, so we're going to go to Downloads. That's where I've got it. Master, GRBL master, and move this out of the way so we can see a little bit. So I've gone to GRBL master. We then select the GRBL folder inside the GRBL master. When asked to select a library folder you would like to add, the correct folder only contains the source files. So we've selected that and we'll go Open. Already exists because I've actually already installed this, so I've got a copy message. It will install. Then what we do is we open the GRBL upload Arduino example. File. Examples. Going to GRBL. I'm going to go GRBL upload. So compile and upload GRBL to your Arduino. So we are going to, we've compiled it, so we can verify it. Compiling sketch. And up it loads. Oh, sorry, it's verifying. Compiling. Okay, so it's done compiling. And then all we need to do is upload it to our board. We make sure we're still connected, which we are. So we'll go upload. It's compiling the sketch and uploading it. Done. So we've uploaded it. Now what we need to do is click on the serial monitor button. And we should come up with a welcome message like this, which is our latest version of GRBL, which means we have successfully installed it. Now, important to note, both NL, so new line and carriage return, needs to be selected, and the baud rate needs to be at 11.5200 for the new version of GRBL to communicate to it. If you don't have those set, it won't communicate correctly. And then if we press $, it should show up our GRBL settings. So $, is GRBL settings, but we'll get more into that later on. And that is in downloading Arduino, installing and uploading GRBL to our Arduino Uno board.
Okay, so we've got our stepper motors here, our stepper drivers, the CNC shield, and at the back here I've got the Arduino. What I have done is I've actually removed one of the Polarlu DRV8825 stepper drivers off the board, just to show you underneath here we have a 3 sets of pins. So you've got mode 0, mode 1, mode 2. Now the DRV8825s, you can set 8 different step positions or micro step resolutions. If you have a jumper off, then it's full step. So each step will do 1 full revolution on the motor. If you go high, so high is when you put a jumper on. So if we put a jumper on the first lot of pins and leave the other 2 off, that is half a step. At the moment, I've got mine set to quarter step. So each step will rotate the spindle 1/4 turn. It'll go up to a 1/32 resolution. The problem is if you do go up that high, you lose torque on the motor. So at the moment, I'm going to set it for quarter step. We'll see how we go. I might in the future look at an 1/8 or a 1/16 step, depending on what sort of resolution, so how finely tuned we can get the machine once it's actually assembled. But for this testing and that, just to make sure everything's working, I thought we'll go quarter step and we'll then start the install process. So literally putting the little stepper driver in to the assembly is pretty much just pushing it in like so we're all stepped in. There's a little potentiometer on here as well, which I'll talk about later, but you can actually tune it to a voltage, tune the voltage on it, so increase the voltage to your motors. And that's important once we get this connected up. If there's any sort of juddering or jarring or drop steps within the motor, sometimes you've got to adjust the voltage that they're actually getting. So we'll get into that. So what we'll do now is we'll start the assembly. So really what I want to do is get my Uno board. Now I'm just going to try and do this so you can see, but my Uno board, I'll pull the USB cable out. We'll line this up, making sure we can, and we'll click that in, so that's all clipped in. And now what we want to do is put our motors on. So we've got these little pieces of paper that I'm just going to sit on the top. I've also gone ahead and marked each of the cables with the corresponding axis that it sits on. So what we'll do is I'm going to connect these up. So we'll connect up Y. You also want to make sure that these connectors are sitting the right way. Now I think with this one I have all the wires so that all the wires sit in the banks. It doesn't really matter because you found your pairs, but it's very tight with these connectors, so sometimes I actually have to just sort of twist them around to make sure I've got them in the right spot. So that one looks comfortable. Now with my clone, my Y clone, we have to reverse one of the pairs. So what I'm going to do is I'm going to make sure that this black and green wire, so I'll just see if you can see, so we've got black and green here. It goes green, black, red, blue. So what I'm going to do is I'm going to go green, black here, but instead of red, blue, I'm going to go blue, red, because you would just have to reverse one of the pairs. So we'll try and get that on without bending any pins. So I've got green, black, red, blue, green, black, blue, red. So that's reverse the directions of this one, because they're going to sit opposite. They need to run in an opposite direction. So we'll go on to our Z-axis, which is in here. Actually, I'm going to have to turn that around because it's quite tight. And then we'll do the same with our X. Get that in there. So we've got all our motors connected. I've got two sets of jumpers down here, which is going to clone my Y-axis. So they'll clone these two. And then all we need to do is we will wire in. Now the power supply is turned off. I do have a fan here, but it's a 12-volt fan, so it's not going to run unless I get a step down on it. What we'll do is we will get this wired in and connected. Now, whenever you connect componentry, make sure it's turned off and the USB is unplugged, so there's no power going to the board, because there's a good chance that you could actually damage the board if you hot plug it. So what I'm going to do is I'm going to go grab a screwdriver, little flat blade screwdriver, so I can get these power jacks wired in, making sure that I take special note of positive and negative, and then we'll plug the power supply in and come back. Oh, sorry, and finally, one last thing. All we have to do is connect our USB cable to my laptop. So I'll do that and then we'll come back. Okay, so we're all connected up. Power is wired in just here, positive, negative. We'll just double check that it's correct. Yep, so the polarity is correct. And what I'm going to do is I'm going to plug the power supply in now, just so you guys can see. I've also plugged the USB cable into my laptop. So let's power on the power supply. So we've got power. Nothing's smoking, so that's a good sign. That's excellent. And what we'll do is I'll open up Universal G-Code Sender and see if we can't jog some motors. Okay, so we've got Universal G-Code Sender up and running. We're just making sure that our COM port is 18 and our communication rate, our baud rate is 115200. So we'll hit open and you would have heard a clunk. That's sending signal. That's a good sign. It means that we've connected to our board and the motors have now got power. So let's see if we can jog these things. So let's try machine control. We'll try the step size 1 first, and let's see. We'll try and jog our X axis. So this one here, we'll see if we can get that one to move. Excellent. Awesome. And you'll notice here that our machine work position is 3, our machine position is 2. Now we'll try and get the Y, actually we'll try Z axis first. We'll move this way. Excellent. Now Y, these technically should spin the opposite direction to one another. So let's see. Oh, what happened there? Okay, so our Y must be a connection. Usually, I think that means there's usually a connection issue. Just make sure we've got connected. We'll try again. So our Y is working on this one, but our clone seems to be a bit crazy. All right, folks, let's play around with these connectors and see if we can't get these motors or this Y clone one working. So just bear with me. Okay, so it looks as though we had a connection issue here with the splitter on the Y clone. The pins weren't quite touching, so I've got a feeling that the signal was cutting in and out, which is why, or it was only going to one coil, which is why we had this shutter on the motor. So let's try it again. Okay, let me just hold this. So we've got contact. There we go. And they're rotating in the opposite direction. I hope you can see. Just move my arm out of the way. So what I might do is let me play around with this connector, see if we can't get it a solid connection, because if I'm going to send a file using the browser here and with the visualizer, then I'm going to have to make sure it's connected properly. Otherwise, this motor is just going to jump around and make all sorts of noise. So let me play around with these connections again and see if we can't get a more solid connection, and then we'll send a file through. Okay, so what I've done is I've connected up. I've just switched the Y cables around here. Just to give me a solid connection. So you'll notice that they're rotating the other way. I've actually switched the directions around as well. That gave me a more solid connection. So let's jump into file mode
and see if I can find a file, which I've saved one on my desktop earlier called this. So let's have a look at this. Visualize. This is the one I showed in the last video. So what we might do is let's send this over and see what happens. Let me first reset, return to 0. Cool. This is awesome, folks. This is really, really cool. So let's check our visualization. Let's start. I want to see how hot these are getting, because apparently I'm pushing max on these drivers, so I don't want them to get too hot. So let's see. Let's try and let's send this file through and see what happens. Oops. Oh, we've got some action. Now I've also got a laser thermometer here, so we'll just see how hot these little things are going to get. $37, 42. Let's look at this and see what we got. It's looking at about 51 degrees at the moment. For you people in the States, I'll get a Fahrenheit reading as well. We're looking at anywhere from 136 to, that's the highest Fahrenheit reading I've got, 152.3, which equates to, battery's just gone flat, but look at, so I've got a bit of creep on this one here. Not sure what's going on there. Maybe a bit of crosstalk. But pretty cool, folks. And as you can see, it's sending through all the G-code through here. Our little markers cutting out our Z. Oh, this is going to be excellent once we get the linear rails complete and get the front and get this sort of all connected up and get it driving along and be able to move it around. Just going to touch these. Oh yeah, they're getting a bit warm. $73 degrees, 164 degrees Fahrenheit. So we might just cancel this program, I think, just to let these things cool down, because it's recommended to have a fan on it. So we'll just pause the file. Now down the track, I'm looking to hook up those buttons that I bought recently, the yellow, red, and green, and they I'll be utilizing those to use the resume, hold, and abort buttons. We'll get to those later on. I've also bought I've got some little terminals that are probably better suited here for the PCB board for the shield.
Well, I'd say that was a pretty good success. I didn't adjust really any settings because I've been quite lucky. Everything's sort of been plugged in and started working, so I don't think I will play around too much. I talked about changing or adjusting the potentiometers on the board. I'm happy. They're at full voltage. I took a voltage reading on them. I believe they're at full voltage, or max setting anyway. And the motors didn't have they didn't get hot. The drivers got really hot, and after doing some further reading, you'd need to have a fan blowing air on them to keep them cool, otherwise it'll burn the chip out. That's why they come with those little heat sinks, but I would recommend putting a fan blowing over those heat sinks, because they were at 65, 70 degrees, getting quite warm, and that only got halfway through the file. So if you ran the machine for an hour or so, or even longer, depending on what you're doing, I think they may come close to burning out. But I am pushing the limits of this particular setup. So as I said, we'll learn. Obviously, we learn as we go. Next, we'll look at building the table. So we'll take some shots out through the out of the shed and do some fabrication work out there. I'm not the world's best fabricator or metal worker, as you'll see. If you want good welding videos, go to welding tips and tricks on YouTube and weldingtipsandtricks.com. Jody he's just a tremendous teacher, and his videos are absolutely outstanding. So go over there and check him out if you're new to welding. So I've got to go and order some steel now, so it'll be a case of trying to save up a bit of cash and get the steel cut. I might even ask them to cut it to length. We'll see how we go, what the processing fee of that is. Last time I checked, I think it was about $30 for them to cut it all to length, and I got a quote. It's about nearly $200 worth of steel plus the processing fee. So we'll wait and see. We'll see how we go. Until then, I am going to do some more research and testing of these motors to see if we can't fine-tune them using the GRBL software. But from I guess a hardware perspective, electronics perspective, I'm pretty happy with how we are at the moment. And I'm also going to be gathering some more bits. I've got to get an emergency stop. And I also would like to hook up or try and look to building a chassis or a case for the electronics components. I've looked around, there's a couple of possibilities online that I might have a look at. But until then, again, thanks for watching. Please rate, comment, subscribe. If I've done something wrong, please let me know. As I said, I'm a novice to this, so if you don't tell me, I won't learn. But again, thanks for watching, and until next time, see ya.